Welcome to the fourth lesson of our WireGuard VPN course on Mikrotik RouterOS. In this lesson, we are going to explore the creation of the VPN tunnel between Berlin office and Paris office. We will start from Berlin office settings. So let's connect to the Berlin office via Winbox. We will connect to the ROM to our ISP router. We see in the list London, Berlin and Paris. We need Berlin. We say connect. As you can see, we are on the Berlin office router OS. And we have a similar rules that we have on our London office. Everything is same. The interface list is same. The difference is the IP addresses that we used. So we used 172.16.2.2 on our Ethernet or Internet interface, and we have implemented 192.168.2.1/24 on our bridge interface. So let's compare it to the actual topology if we did it right way. 192.168.2.1, 192.168.2.0, 172.16.2.2, 172.16.2.2, and the default gateway is 1. Let's see that default gateway in IP routes. In IP routes, we set the default gateway 0.0.0.0/0, and the gateway is 172.16.2.1, which is this interface of the ISP router. If we look into the interface lists, we have bridge 1 in LAN and Ether 1 in 1 interface lists. Again, we are using NAT, we are source NATing. Out interface Ethernet 1, action masquerade. In this case, we are hiding our local area network of Berlin office, this network 2.0, to the ISP. So ISP doesn't know about our local area network. The tunnel IP address, which is planned for the VPN WireGuard, is 10.10.10.2/24. So let's start building the tunnel interface. Let's check that we have internet connectivity. Let's say ping 8.8.8.8. And we are able to ping the internet. It means that our network from here via ISP to the internet is working. So it means that we can also build the tunnel via the ISP router to our Paris headquarter router. We will start from the WireGuard interface creation. We'll say plus. And we will name it as WireGuard from Berlin to Paris client. And we say apply. We have automatically generated the public key for the WireGuard, which we'll use on the foreign site. And the foreign site is our Paris headquarter office. Let's copy it. Let's also log into the Paris headquarter router. Now we are on Paris headquarter office. We don't need to do anything other than creating a peer interface on the WireGuard so far. So we open WireGuard peer. We already have one peer which is looking to the London. We add another one. Let's zoom it. And we will call this peer as peer for Berlin office. We will use the existing WireGuard server interface on Paris headquarter, and we will paste the public key which we just copied from the Berlin office. We don't need private key, we don't need endpoint, we don't need endpoint port, but we need to specify the IP addresses which are available on Berlin office. In this case, it should be 10.10.10.2/32. It's only one IP address there, which is remote VPN tunnel client IP address. And the second network should be 192.168.2.0/24, which is the local area network on Berlin office. Let's generate a pre-shared key for additional security. Let's say auto. And let's add the keep alive for 20 seconds. And let's click apply. We can see that the pre-shared key was generated. Let's copy it so that we can paste it on the far side of the Berlin office. We go to Berlin office. We don't have any peer created yet. Let's create one. Let's call it Paris HQ office. We will use just created interface of the WireGuard on the Berlin office. We will paste the pre-shared key which was generated on the Paris office peer client automatically, and now we need the public key from the Paris interface of the WireGuard. Let's go to the Paris office WireGuard interface and copy this public key. Let's go back to Berlin office and paste this public key into the new created WireGuard peer. We don't need to specify the private key, but we need to specify the Paris office headquarter public IP address interface on the Paris headquarter router. It should be 172.16.3.2. And the port should be UDP 443. The allowed IP address can be left as default 0.0.0.0/0 for the IPv4. And we can set the persistent keep alive for 20 seconds. That's all. Let's click apply. And as you can see here, we already have a connectivity between Berlin and Paris office. We see RX, TX, and the last handshake counter has started. We say OK here. Let's go to the Paris site and see if we see similar statistics on the peer of Berlin. We see that there is RX and TX packet counters, and last handshake counter also activated. So looks like the tunnel is up. Let's assign IP address to the tunnel interfaces. We already have assigned an IP address to the Paris site. It's 10.10.10.1/24. Let's assign to the Berlin site. We go to IP addresses. Select interface WireGuard from Berlin to Paris client. Say apply. 10.10.10.2/24, and it was in the disabled state. Let's enable it. Okay, now we have IP address on the Paris side and we have an IP address on the client side. What else we need to do is to say to the Berlin office which network is available on the Paris side. We have to go to IP, routes, and we should say that which network we are focused on. We are focused on network 192.168.3.0. So we should say that (192.168.3.0/24) is available via 10.10.10.1 or this tunnel interface. distance scope and target scope are default. And we should say apply, and we should enable this route because I have created it previously, but it was in the disabled state. Plus we put a comment here to Paris local net. You can put a comment in the comments section here so that you also know for which destination you have activated this route. Let's see what is available on the Paris site. So Paris site should also know about our local network 192.168.2.0 so that it can route packets correctly without dropping them. We should go to IP routes. And we see that I have prepared here a route, but it's in the disabled state. So routes can be added by clicking on the plus button. As it is already registered here, but in the disabled state, I will just double click it. As you can see, it says 192.168.2.0/24, which is this network, is available via 10.10.10.2, which is this interface. And we say apply, and we say enable, and we say OK. In this way, our Paris router knows that if it wants to send a packet to 192.168.2.0, it should use the tunnel interface of the remote Berlin VPN interface. It should use its IP address. So let's check now if the connectivity is working between these two local area networks. We go to Berlin computer. Open. Username is user and the user password is test123. And we open the Paris site server computer also. Test123. While it is being loaded, let's test connectivity from Berlin computer to Paris server. We click on command line interface and say ping 192.168.3.100. 100 is the IP address of the server. And as you can see, we can ping it. Let's trace route to the same destination to understand how the route goes. Trace route. And as you can see, it goes to 192.168.2.1, which is router interface on Berlin office network. Then it goes to 10.10.10.1, which is the far end side, which is headquarter VPN tunnel interface. Then it goes to 192.168.3.100, which is the IP address of the server. So we see that the connectivity from Berlin office goes to Berlin router, goes to ISP router, goes to Paris headquarter router, and then reach the server site IP address. Now let's see if we have similar connectivity from the server side to the Berlin side. By the way, we didn't check what kind of IP address was assigned to the Berlin computer. Let's say ipconfig. And it was assigned IP address of 192.168.2.254. So that let's ping it. Ping 192.168.2.254. As you can see, the server can ping the Berlin computer. Let's do the trace route. As you can see, the server is tracing route via 192.168.3.1, which is the office local area network gateway on the router of the Paris. Then it goes to 10.10.10.2, which is the far end side tunnel interface IP address. Then it's being routed to 192.168.2.254 Berlin computer interface. So it looks like bidirectional connectivity is fully functional. Okay, now let's check that the London office can ping the Berlin office. For this, we can open the London office computer. Test 1, 2, 3. Command prompt. Let's check its IP address, ipconfig. It has IP in the range of 1.254. And let's say ping, first of all, the server address on the Paris headquarter 192.168.3.100. Yes, it can still ping it. Let's check if it can ping the interface of 10.10.10.2, which is the Berlin office. 10.10.10.2. It cannot ping it. Let's check if it can ping the IP address of 192.168.2.254. 254. Let's see why the London office PC cannot ping the tunnel interface of 10.10.10.2. Let's make non-stopping ping, continuous ping. And let's go to the Berlin office. Berlin office, this one. And let's see if the interface which belongs to the VPN tunnel is added to the LAN list. Let's go to the interfaces, interface list. It's not added. That's why the firewall is blocking it. If we look into the IP firewall, we should see that there should be some counters here which are dropping the pings. You see? So how can we improve the situation? We should say interfaces, interface list, add to the LAN interface list the new created WireGuard interface, say apply. Okay, and enable. Let's try again. You see, it still cannot ping it. Let's check if the London office can ping the interface of the Paris headquarter, which was working from our previous tests on the previous lesson. So we ping 10.10.10.3, which is London office interface, okay. And 10.10.10.1, which is Paris office interface. But still 10.10.10.3 is 3.2 is not pingable. But our London office should know about Berlin office address. How? Let's go to the London office Mikrotik router. Let's check the IP routes. In the IP routes, we have a default gateway set to our ISP, and in our IP routes, we have a 10.10.10.0/24 is available via WireGuard interface. So the system should be sending the pings, but is not getting responses. If we go to the WireGuard interface peer configuration, we see that allowed address list is everything is allowed, so nothing is blocking. Then we should go to the Paris side, then check maybe the Paris side is blocking. Let's see if Paris side can reach this interface from its server computer. Server computer is this one. We say ping 10.10.10.2. And as you can see, the Paris server is able to ping this interface. What does it mean? It means that the Berlin office doesn't know about the presence of network 192.168.1.0/24 because the packet is going like this through the tunnel, reaches the internet IP address on the Berlin side, and Berlin office says, oh, the packet is coming from 192.168.1.254 and I don't know where is it, and it's sending it back to the default gateway to the ISP, but it should send it to the tunnel interface. What does it mean? It means that we should set the route of 192.168.1.0/24 on the Berlin office router. Let's do it. Berlin office router is this one. IP routes. And we have a prepared route for this case. We have 192.168.1.0/24, which is London office LAN, available via Paris gateway 10.10.10.1, this point. And we say enable it. After we enable it, now the Berlin office router knows how to send correctly the pings to London office computers. And as you can see, we started to see the reply from 10.10.10.2. So now, because the Berlin office knows how to respond to requests from 192.168.1.0 network, it should respond it to the tunnel, not to the default gateway of the ISP. Everything starts to work. Let's see if the same is working from Berlin office. Computer. Which one is Berlin? This one. We say ping 192.168.1.254 is still not responding. Let's check if the VPN address is responding on the London site. 10.10.10.3. As you can see, it's also not responding. Most probably it doesn't know where the 192.168.2.0 network is located, and also doing the same job, sending replies to the default gateway. Let's see. Let's make it with a T so that we know when the problem was resolved. So now we need London office Mikrotik. Go to IP routes, it's here. And as you can see, we have a route prepared for this case. We double click and say 192.168.2.0/24. This network is available via Paris gateway or Paris VPN tunnel. This tunnel. Let's say enable, OK. Let's see, and as you can see, the Berlin office now is getting responses from 10.10.10.3 from here. Let's check if it can ping the London office computer now. And as you can see, it can ping the London office computer now. So we have fully bidirectional communication between these two networks, London office and Berlin office, via Paris office. Let's check if this is the reality. Let's say T. And let's analyze the traffic which is on the tunnel IP address of the Mikrotik in the Paris office. Let's go to Paris office. This is Paris office. And let's go to interfaces. Let's find the WireGuard interface and say torch. And as you can see on the WireGuard interface, we see ICMP traffic from 192.168.1.254 from London office, destined to 10.10.10.2. Looks like there are some other pings ongoing. Let's stop them. 10.10.10.2, this one. We stop them. And now we see only the pings which are going through the headquarter office from 192.168.2.254 from Berlin office PC to 192.168.1.254, which is London office PC. So we have a bidirectional full connectivity visible on the VPN tunnel from London office like this to Paris, and from Paris office to Berlin office like this. This kind of configuration is called hub and spoke. Hub and spoke, hub in this case is Paris headquarter router, and spokes are London and Berlin office routers. Why we may need to tunnel the traffic via the Paris office headquarter? Why not just directly build one more VPN tunnel between London and Berlin offices? We may need it in the situations where you have a private IP address on your one interface of your London office router, and you have also private IP address on the one interface on your Berlin office router, but you have a public IP address on your one interface of your Paris headquarter router. For WireGuard to operate, the server side should have public IP address on the one interface. There is no any requirement to have a public IP address on the client side. So client side, without using private IP address range with internet connectivity, can build a tunnel between Berlin office and Paris office, and the same between London office and the Paris office. So if you have a shortage of public IPv4 addresses and are not able to acquire the IPv4 public address, the hub and spoke connectivity will be required. There could be another situation where you may need a hub and spoke connectivity. Let's imagine where we have a Paris headquarter office and we have here the ATS, the switch for the IP telephony, which is the server of the IP telephony at the same time, which is installed on the headquarter office. And you need to record all the communication between clients which are connected to that IP telephony server. In order to record all these communications, the traffic should pass through the headquarter office. What does it mean? It means that if you have some IP telephony client software on your London PC and your Berlin PC, and you want to communicate with a person from London to Berlin PC or vice versa, the traffic should pass through the Paris headquarter office so that it could be recorded. In this case, you also need hub and spoke connectivity. At the same time, we provide the privacy for the traffic, which is fully encrypted via WireGuard tunnel. There could be other situations or cases where you may need hub and spoke connectivity, which we are not going to discuss in this course. We have reached the end of this lesson where we have demonstrated that one more side-to-side connectivity is functional, plus we have a hub and spoke connectivity where Berlin office can reach not only Paris office resources, but also it can reach another office resources, in our case it's London office, via the Paris headquarter router tunnel. This is all what I wanted to show you in this lesson. If you have any questions, you can ask them in the comment section of the video. In the next lesson, we are going to explore the road barrier mobile client configuration, which is quite interesting. See you on the next lesson. I highly recommend subscribing to my YouTube channel so that you don't miss any new lessons or setup guides that I release.